Hi, welcome to the third problem of the series. So again, I haven't solved this question earlier and I'm going to solve it along with you all. So we're going to read the question, break it down and note everything that we see. Because that should be the first problem solving instinct. To note down everything that you read and recall all the information accurately. So the car starts moving rectilinearly, which means that it's moving in one direction only. First, with an acceleration omega equal to 5 meters per second squared. So let's just break the total motion into intervals of time, okay? So from t equal to 0 to t equal to t1, we can say that the car is moving with a constant acceleration of 5 meters per second squared in this direction. So this direction I'm taking to be positive, right? Then it moves uniformly. So from t equal to t1 to t equal to t2, the car is moving uniformly. That means acceleration is 0 and velocity is constant. And then from t equal to t2 to t equal to t3, it is decelerating at the same rate omega and comes to a stop. So a is nothing but minus 5 meters per second squared. Yeah, this is all that's been given in the first part of the question. The total time of motion equals 25 seconds. So t1 plus t2 plus t3 is not equal to 25 seconds, because you need to understand t1, t2, t3 are absolute time intervals taken with respect to the initial point or initial time that we've chosen, right? So the total time that the car is in motion is actually just t3. It's not t1 plus t2 plus t3, because these are absolute time in space, right? So t3 is 25 seconds. So this is one information given in the question. The average velocity during the time is equal to 72 kilometers per hour. So V average is equal to 72 kilometers per hour. Now let's just convert it into meters per second, since the acceleration is given in meters per second squared. So 1 kilometer is 1000 meter divided by 3600 seconds, because that constitutes 1 hour. 0 cancel out, and this is twice, so 20 meters per second, right? This is the average velocity. Now what's the definition of fundamental meaning of average velocity? V average is nothing but total displacement vector, because V itself is a vector, right? So total displacement by total time interval of motion, right? Now what's the total time? Total time is nothing but t3, which is 25 seconds, and we know V average is 20 meters per second because that's been given in the question. So total displacement, which is S, is nothing but V average, which is 20 into 25, which is total time. So this is nothing but 500 meters, right? Now we also know that the displacement, the instantaneous displacement, is nothing but V instantaneous into dt, because that is how V instantaneous is defined, right? ds by dt. So when you sum this up, or in other words, when you take integral on both sides, what you get on left hand side is just the total displacement of the particle is equal to integral from t1 to t2 of v dt, where v is velocity vector. So this gives us a hint that we need to solve the question graphically, because it involves integration of v dt, which is nothing but integration of something like f of x dx, right? Which is just the area of a graph. So let's just do it graphically. If we make a plot of velocity time graph, this is the velocity axis and this is the time axis. Now this is t1, this is t2, and this is t3. I do not intend for them to be equally spaced. It's just that the way the graph has come to be right now. So we've been told that during 0 to t1 interval, it moves with constant acceleration. That means that the velocity as a function of time is a constant. It has a constant slope, because v is equal to at. From the first law of motion, which had been derived for constant acceleration, obviously. Its slope has been given to be 5 meters per second squared, right? Then it moves with constant velocity till time t2 and then decelerates with the same negative slope, you can say minus 5 meters per second squared, and comes to rest at an interval t3. So when you plot the points t1 comma 5 times t1 this would be again t2 comma 5 times t1. The altitude does not change because it's moving with constant velocity, so the velocity would remain the same, and that's why the y coordinate remains the same. And this would be t3 comma 0. Now if you look at it, what is v dt ka integral from 0 to t3? It's nothing but the area of this graph. So we need to calculate the area of this graph, which can be done easily. Let's just break it into two rectangles, one rectangle and two triangles. So the area of the graph is the sum of these two triangles and the rectangle, right? So area is nothing but total displacement, which is nothing but half into t1 into 5 times t1, which is area of the first triangle. But now if you look at it, the area of the first triangle and the area of the second triangle will be the same. They are symmetric, right? Because t1 minus 0 is equal to t3 minus t2. In fact, let's just write it down. This could give us another equation. T1 minus 0 is nothing but t3 minus t2. T1 plus t2 is nothing but t3, which is 25 seconds. Now, why do I say so? Because if you look at it, let's assume that this constant velocity is v0. Now for 0 से t1 interval, v0 is equal to 0 plus 5 times t, where t is the motion of period of motion. v0 by 5 is nothing but t1 minus 0, right? And for t2 to t3 interval, again the slope is constant and it's decelerating with a constant deceleration. So you can use the first equation of motion and you can say v0 minus 5t is nothing but 0. v0 by 5 is equal to t, and in this case t would be nothing but t3 minus t2. So when you equate these two, t3 minus t2 is equal to t1. So t1 plus t2 would be equal to t3, which is equal to 25. So that's why the area of the two triangles also have to be the same, because the height is the same as well as the base of both the triangles is the same. So you can just multiply this by 2 plus the area of the rectangle, which is nothing but t2 minus t1 into 5 times t1. So this gives you 5t1 square plus 5 times t1 t2 minus 5t1 square. So 5 t1 t2 is the area of the graph, which is nothing but a total displacement. Now total displacement is also equal to 500 meters. So 5 t1 t2 is nothing but 500 meters. t1 t2 is nothing but 100 meters. 100, not meters exactly, just 100, because we're dealing in magnitudes at this point of time. So we need to find the total interval during which the car moves uniformly. So basically to find t2 minus t1. So we've got two equations in t1 and t2, right? So this is one equation, t1 into t2, t1 t2 is 100 and t1 plus t2 is nothing but 25. t1 plus t2 is 25. So let's make use of these equations, because then we can form a quadratic in either variable, then solve for that variable, and then we can just simply find t2 minus t1. So let's just make it quick. So we can plug t1 as t2 by 100. So t2 by 100 plus t2 is nothing but 25. t2 square plus, pardon me, this has to be 100 by t2 plus 100 is nothing but 25 t2. t2 square minus 25 t2 plus 100 is equal to 0. When you factorize this, t2 minus 20, t2 minus 5 is equal to 0. t2 is equal to 20 or t2 is equal to 5. This implies t1 is 5 or t1 is 20, because the sum of t1 and t2 has to be 25. If you look at it graphically, t2 is more than t1, because that is what something we'd assumed without loss of generality. So this case is rejected because t1 can't be greater than t2. So t1 is equal to 5 and t2 is equal to 20. So t2 minus t1 is equal to 15. So the final answer is 15 seconds, and that is what the question is asking. Answer is equal to 15 seconds.